All right, so now we move into lesson 7a of the polynomials unit, and we're going to be dealing with factoring polynomials of the form ax squared plus bx plus c. So when I look at multiplying binomials, well, I can start by visualizing them using algebra tiles. So if I want to visualize them using algebra tiles, well, if I look at example A below, they've already set up the algebra tile system for us. We just have to identify what represents what here from our binomials. So if I have an x plus a 3, well, we're going to indicate that our x units are the rectangles and each of the small squares is represented by a single unit. Meaning on my top side here, I have x plus 1 plus 1 plus 1, that's x plus 3. And similarly, I can take my binomial here and place x here and each individual one here being x plus 2. Now I want to fill this in by multiplying the two sides together. If I take x and multiply it by x, this is equal to x squared. So I can place x squared here. If I multiply x times each of the ones below, I'm going to have x times 1, which is a single x, and I'm going to have x times 1, which is a single x below here. Now I take my x and I multiply it to all three of these ones, and that's going to give me x here. I'm going to have x times 1, which is x, and x times 1, which is x here. And now finally, I want to take each of the ones and multiply it to all three. Each of the ones and then multiply it to all three. So with this expansion, I'm going to have 1 times 1 6 times, which will give me 6 individual blocks here. Now, if I want to express this as whatever polynomial term I have, well, I have x squared or 1x squared. I have 5 of the x terms, and I have 6 of the individual ones. So this is from factored into my trinomial. All right, let's look at another example here. Instead, I have x minus 3 and 2x minus 1. If I have unshaded blocks, those represent negatives. So I'm going to do the same thing I did before, where x is represented by my rectangles, and the negative ones, or the negative values, are going to be represented by the unshaded blocks here. So my 2x minus 1 is represented on the left, and my x minus 3 is represented on the top here. When the expansion is done, we're going to do x times x, which gives me x squared. We do another x times x, which gives us the block below of x squared. Now I do x times a negative 1, which will give me negative x. I can go from here, x times each of these ones, and that's going to give me a negative x. Negative 1 times another x is negative x. Finally, we have another negative x, because negative 1 times that x. And we repeat the same thing for the x below. We're going to multiply it to all three of these ones. This is going to become a negative x with another negative x and one more negative x. Finally, I'm going to take my negative 1 and multiply it to all three of these negative ones. And we know that anytime there's a negative 1 times a negative 1, it's going to be positive. So these should each be a plus 1. Now, if I count up the blocks on the interior, I have 2 of the x squared cubes. I have negative 7 x's, or negative 7 of those x terms. And then finally, I have plus 3 units represented by the individual squares at the bottom. So I've taken something that is a binomial times a binomial and now written it as a trinomial using a visual of these algebra tiles. All right, so now representing these as a binomial times binomial with algebra tiles, okay, we're going to take something that's a trinomial now and work backwards. So if I draw this out, according to what I've been given 1x squared. And I've been given 6 x terms. So I'm going to draw 3 rectangles, 3 to the right, 3 below. So I have an x, an x, an x, 3 more x's below, and now I need to allocate my 9 units, or the 9 at the end. So each of these will get 3. And therefore, if I was to go up and discover what my binomials are that are represented on the outside here, well, we know in order to get an x squared, I have to write this as x times x. In order to get my x values here, or the individual x's here, I have to take an x and multiply it by a 1 block, a 1 block, and a 1 block. And then finally, if I want to get the x's below here, well, I had to multiply x by each individual one. And we know all of these interior ones, they're going to come from going 1 times 1 gives me 1. 1 times 1 gives me 1. And I could continue the pattern all along and fill these through. Therefore, if I represent this as a binomial times binomial, it is x plus 3, which is represented on the top. And then I have x plus 3, which is represented on the side or the vertical column. Now we know two things that are the same factor written twice. I can say this is x plus 3 squared. Any number that's written out twice like this, no matter if it's a monomial or binomial, we can square it, meaning that it was written out twice. Now I go over to my second example here, and I can draw out my table once again, and I'm going to fill this in. I have 1a squared, which I'll put here. I have 7 a's to allocate, so maybe I'll put 3 here, and then 4 below. 1, 2, 3, and 4. And these are all individual a terms. And then finally, I have the 12 to allocate here, or the 12 individual units, which I will draw in below here. So we're at 6, 7, 8, 9, 10, 11, and 12. And those all represent ones units. Now, we know in order to get an a squared, I have to multiply a by a. So those are my first two blocks on the outside is an a by a. In order to get these each individual a's here, well, we got a squared by going a times a. Now I need to do a times an individual 1, times an individual 1, and times an individual 1. And similarly below, in order to get the 4 a's here, I had to multiply the a by 4 individual 1s in order to get back to that a there. Now, I had 1 times each of the 1s, and that fills out the 12 that are in here. Now, if I want to represent this as a binomial times binomial, I look at the top side here and I go, well, I have a plus 3 individual units. My second one, or my vertical one, is a plus 4 units. And since these aren't the same, that is our binomial times binomial, or our trinomial in factored form, or as a product of two binomials. All right, so before we continue, we're going to do an expand and simplify activity, or using foiling or box method. So for this, what I'm going to do is I'm going to actually show foiling, but you can use box method as well. So in order to expand this, I need to take my first term and multiply it to the two terms in the next bracket. This is equal to x times x, which is x squared, x times 2, which is 2x. And now I need to go negative 4 times x, negative 4 times 2. This is negative 4x. Negative 4 times 2 is negative 8. Now, if I combine the like terms, negative 2, or positive 2, my bad, and negative 4x are going to come together. This is x squared minus 2x minus 8. So we've taken a binomial times a binomial, multiplied them, or the product of two binomials, and we got a trinomial out of them. All right, let's do one more example here. So I take my c times the c times the negative 7. This is equal to c squared minus 7c. Now I go to my second term, and I go multiply to each of the ones in the next binomial. This is going to be plus 3c. 3 times the negative 7 is negative 21. And now I just need to collect the like terms. Negative 7c plus 3c is negative 4c. And so now the product of these two binomials is equal to c squared minus 4c minus 21, which is a trinomial. All right, let's flip over the page here. Now we really get into the meat and potatoes of the factoring side of things here. So we're going to introduce some steps in order to be able to factor a trinomial into two binomials or binomial factors. So if I take the statement x squared minus 2x minus 8, well, let's list some things that first of all multiply to make negative 8. So those things could be 1 times negative 8. I could write negative 1 times positive 8. I could write 2 times negative 4. And then I could write negative 2 times a positive 4. All of these things will multiply to make 8. Now, I want to add together these two numbers instead. So 1 minus 8 is equal to negative 7. If I go negative 1 plus 8 is positive 7. 2 plus a negative 4 is negative 2. And finally, negative 2 plus a 4 is equal to positive 2. Now, here's where we need to build the connection. We figured that we had to multiply to make the outside number here. We had to multiply to get this number. I now have to add to make the middle number. So I have to add to make this middle number. So we want to say for our step 2, if we've listed out what multiplies and then the addition of those or the sum of those, then circle or highlight the factors that work here. What we're saying is that we need to figure out what will multiply to make negative 8 and then add to make negative 2. It would be this column here. If we put together the 2 and 4 or negative 4 as our factors, this will work. Now, we're going to set up what we learned in the previous lesson. If I take this trinomial and I break apart the middle into two numbers or these factors, then I'm going to have a positive 2 and a negative 4. And what we can do is we can confirm that this works because if I take positive 2x and negative 4x and I combine them together, I get negative 2x. So this is a quick way to show that we've done this correctly. Now we want to factor by grouping here. I group my first two, I group the last two terms, and now I need to take out something common from each of those groups. From x squared and 2x, I can take out a common x, leaving me with x plus 2. From negative 4x and negative 8, I can take out a negative 4, leaving me with an x plus 2. Because we know if we remove a negative, both of those signs are going to change. Finally, I have a GCF term of that x plus 2. The x plus 2 is common between them, so I put it out front. And what was I left with? The x and the negative 4, and they come together to make my second factor. So we've taken a trinomial and factored it into a product of two binomials. Now this involves the skill we learned previously, which was we need a factor by grouping. So we're going to see this a lot in the future here, but just know that factor by grouping was part of the factoring method. All right, let's do another example here. So if we want to completely factor x squared minus 12x plus 35, we want to say, let's start off by figuring out what multiplies to make positive 35. Well, we have 1 times 35. We have negative 1 times negative 35. We have negative 7 times a negative 5. And finally, 7 times 5. Now, let's list the sum of these numbers. Well, 1 plus 35 is 36. Negative 1 plus negative 35 is negative 36. Negative 7 minus 5 is negative 12. And finally, 7 plus 5 is 12. Now remember, the whole point was we wanted to figure out what multiplies to make the outside number and what adds to make the middle number. If this is true, we need to add to make negative 12, meaning my factors are going to be from this column. It is negative 7 and negative 5. So we've circled the factors that work. Now let's use factor by grouping to help us solve this. If I scroll down here, I'm going to rewrite the original statement of x squared minus 12x plus 35. Now, I'm going to replace the middle term by our two terms. So I'm going to take negative 7x minus 5x plus 35. Now, we really want to recheck this because we go, does negative 7 and negative 5x add together to make negative 12x? In this case, it does, so we know we're on the right track. Now we want to factor by grouping. I'm going to take my first two and my last two together. In the first two that I've put together by grouping, well, there's a common x, so I'm going to remove the x out front, and it leaves me with x minus 7. On my second grouping, I have a negative 5x and 35. I'm going to remove a negative 5, leaving me with x minus 35 divided by 5 is 7. And remember that the signs flip. So originally the x term was negative, now it's positive. The 35 was negative, now it's negative because I took the negative out front here. All right, now we want to say, what is the common term here? It's x minus 7. They both share an x minus 7. And what am I left with? The two terms that are connected to those x minus 7s, and they become my second factor. So now I've taken a trinomial, and through the method of grouping, I've been able to factor this into a product of binomials. All right, so let's try an example of our own here. So if I want to completely factor the given trinomial, well, I need to first of all think what multiplies to make my outside term, what multiplies to make the outside, but adds to make my middle term. So a couple things that would multiply to make 7, we could do 7 times 1. We could also do negative 7 times negative 1. Both of these would give me a positive 7. Because we know 7's a prime number, this is it. There's no more things that will multiply to make 7. Now we think, okay, what will in this case add to make the negative 8? We need something that will add to make that negative 8. So the ones that will add to make negative 8 out of these two that we've come up with are these two factors here. Now we're going to factor this by grouping just as we've done before. If I write the original, I have x squared minus 8x plus 7. I'm going to replace the middle number with negative 7x and negative 1x plus 7. Now I can factor by grouping, group my first two, group the last two. I can factor out a common x from the first ones. I'll take the negative 1 off of that x, which results in x minus 7 on the interior. And then I realize I do have this common term here of x minus 7 between the two of these. So x minus 7 goes out front, and now I pair together the two remaining terms of x and negative 1, x minus 1. There are my factors here. All right, now how can you check we factored this correctly? What we can do is we can take this product of binomials and expand it. If I had x minus 7 and x minus 1, well, let's FOIL this. If I take x and multiply it to the 2 in the next bracket, I have this is equal to x times x, which is x squared, x times negative 1, which is negative x. Now I multiply the negative 7 to both terms in the next bracket. This is negative 7x. Negative 7 times a negative 1 is positive 7. So now I collect the like terms. I realize I have a negative 1x and a negative 7x. Those combine together to make x squared minus 8x plus 7. Thus, I've shown that once we had our factored form, we could FOIL it or expand it and get back to our original trinomial. All right, now in the below examples, they say completely factor the following. What we're going to do is I'm going to show or demonstrate a new method here. If I draw an x like the following, I can say what multiplies to make my outside term 24 and adds to make my middle term 10. The two numbers that can do this for me are 6 and 4. So now, if I replace my middle term, x squared plus 6x plus 4x plus 24, I can now move into my factor of grouping by grouping the first two, grouping the last two. An x is common in my first bracket, or my first two, or my first pairing, I should say, and then plus 4, x, 24 divided by 4 is plus 6. The x plus 6 is common, so I have x plus 6 times x plus 4. And there is my factored trinomial. So now I have the product of two binomials. All right, going over to example B, same thing except we see two variables. I don't want you to be worried about this, same process. I can draw my x, and I go, what multiplies to make the outside number, or negative 10, and adds to make the middle number? Well, I would come up with this being 5 and negative 2. So I can replace my inside variable with x squared plus 5xy minus 2xy minus 10y squared. And now I want to factor by grouping. I take my first two and my last two and put them together. This has a common x in the first term, which leaves me with x plus 5y. And if I take out the common parts of the next grouping, well, negative 2xy and negative 10y squared, they share a factor of 2, and they also share a y, leaving me with, on the interior, x. If I take out the negative from here and here, that means that on the interior, they both become a positive. So I have now positive 5y. Now I realize the x plus 5y is attached to both of these. I'm going to write an x plus 5y out front, and I'm left behind with x and negative 2y. X and the negative 2y come together to make my second factor, and there is my factored trinomial. All right, and then with example C, I now have this trinomial, but what we realize is that it's written in ascending order of power. So what I'm going to do is I'm going to say, okay, if this is in ascending order of power or degree, I'm going to rewrite it so that it looks similar to the other problems we've been dealing with this far. There we go. Now we realize we have to multiply to make that outside number, or negative 24, and add to make the middle number of negative 5. Well, the two numbers I can do for this are negative 8 and 3, because negative 8 times 3 is negative 24, and when I add those I get negative 5. Therefore, my solution here is b, well, I should rewrite out the middle term here, b squared minus 8b plus 3b minus 24. If I factor this by grouping, I group my first two, group my last two. Now, in the first grouping, I see there's a common b I can remove out front, leaving me with b minus 8. Now, if I take out a common term from my second grouping, well, 3 is actually something I can remove from both of them. And if I remove a positive 3, I'll be left with b, and negative 24 over 3 is equal to negative 8. Finally, I can take that shared term and write b minus 8 out front, and then write what I've been left behind with, in this case b, and the positive 3 as the other factor. So there is my factored trinomial. All right, now, what if the leading coefficient does not equal 1? What do we do in this case? Well, what do we have to do? We have to take out a GCF from these. So our step 1 is always to look for something we can remove. In this case, I'm going to remove out a common 2, and I can also remove out a common m. They all share at least one m term, and they all share a factor of 2. So what I'm going to do is I'm going to write equal to 2m. If I take each term in this trinomial and I divide it by the 2m, I'm going to be left with 2m cubed over 2m is m squared. Negative 14 over 2 is negative 7. And m squared over m is equal to m. And then negative 36 divided by 2 is negative 18. M over m is m0, or just 1. Now, I'm going to ignore that 2m, because what I want to do is now treat my interior trinomial as something that I want to factor here. So I'm going to say what multiplies to make negative 18 and adds to make negative 7. Well, we could put together negative 9 and a positive 2. So if I rewrite this, replacing my middle term, this is negative 9m plus 2m minus 18. Now, factor by grouping, I take my first two, my last two, and this is equal to 2m. I can remove out a common m from my first pairing, which leaves me with m minus 9. In my second one, I can remove out a common 2, which leaves me with plus 2 negative 18 divided by 2 is negative 9. Finally, I realize I have a common m minus 9, which I write out front. And then what am I left with? The two terms that were the coefficients of that shared term, m plus 2. There is my factored trinomial. So just realize if you can take out a GCF, it's going to remain out front the entire time. And what are you going to have? Another binomial times binomial. All right, let's go over to this example here. So if I see a negative attached here, my first instinct is going to be to say, well, it's not directly equal to just a 1. So what I want to do is I want to remove out that negative. And anytime I remove out a negative out front, it reverses all the signs on the interior. So the positive 5ab is going to become a negative 5ab. The 6b squared is going to become a negative 6b squared. And now that I have something with a positive coefficient on that squared, or the highest degree, what I'm going to do is I'm going to now say what multiplies to make negative 6, or the coefficient of the last term, and adds to make the middle term. So to do this, I can say I have negative 6 and a positive 1, because negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. Now I replace this. I have a squared minus 6ab plus 1ab minus 6b squared. Now I put together the first two terms, the second two terms, and I factor out a common term from each of them. So in the first shared term, or the first pairing, an a can come out, leaving me with a minus 6b. In my second term, I can remove out a common b, meaning I have a plus b, a minus 6b. Okay, now I realize that a minus 6b appears in both terms here. So I'm going to take it and move it out front as the following: a minus 6b times a plus b, where a plus b are the remaining terms, or the coefficients of the shared term. All right, let's make a note here. So if a does not equal 1, we need to look for the GCF that could be removed first, and then we proceed with the factoring of the trinomial. Reason being is because later down the road, if we're not able to take out a GCF, the method of factoring is going to look a little different. It will follow the same process, but we do need to be careful with, if a does not equal 1, then we need to look for that GCF, because things may look a little different when we factor. All right, so example, if we have multiple variables going on, well, we've handled these before. We're going to do a similar approach. If I have to multiply to make a number, I have to multiply to make my outside number, add to make the middle number. What two numbers will multiply to make 8 and add to make 6? Well, I would argue they're 4 and 2. And so now I can substitute that in for the middle. X squared plus 4xy plus 2xy plus 8y squared. If I pair the first two and pair the last two, this is going to be equal to x plus 4y plus the common term of my second one. I can remove out a 2, and I can also remove out a y, leaving me with x plus 8 divided by 2, which is 4, and a y off of y squared is y. Now the common term goes out front, x plus 4y, and the two things I'm left behind with are the coefficients of that shared term, x plus 2y. There is my factored trinomial. All right, now, final example of dealing with one with more than one variable. I'm going to have to multiply to make the outside number 48 and add to make negative 14. The two numbers that can do this for me are negative 8 and negative 6. So now if I go back to this statement, I can substitute those in for the middle value, negative 8ab minus 6ab plus 48b squared. All right, now I pair my first two, pair the last two. I can take out a common a from my first pairing, leaving me with a minus 8b. I can take out a common b and a 6 from the next term, leaving me with a minus 8b, because 48 divided by the negative 6 gives me the 8. And a b off of b squared is b. Now, I take that shared term of a minus 8b, put it out front, and pair together my two coefficient terms, which are a minus 6b. There we go. All right, and lastly, let's look at two examples here that involve what if instead we just give you a variable in the middle and say we want to see what values of k make it so that each of these trinomials are factorable. Well, in each of these cases, the k actually appears in the middle, meaning we need to add to make k and multiply to make that outside number. So what we can do here is we can create a bit of a table and say, if I know I need to multiply to make 24. Well, two things that can multiply to make 24 would be 3 and 8. We could also do things like 4 and 6, 2 and 12, and we could do furthermore things like 1 and 24 even. Now, when they talk about what values of k can be in the middle here, well, we need to take the sum of these digits here such that this is true. So if we have to add to make 24, but then multiply, or if we have to add to make k and multiply to make 24, well, we know these all multiply to make 24, but their sum is equal to, the sum of these digits is equal to 3 plus 8 is equal to 11. 4 plus 6 is equal to 10. 2 plus 12 is equal to 14. 1 plus 24 is equal to 25. So k could be all of these possible values here. Now, k could also be the negatives of each of these. So if I set all of these to a negative, well, k could also equal the negative sums of those. So what I can say here is that this is the plus minus of each of these. It could be the plus minus of all of these, because we know if we had negatives here, it would also work. So k can be any of these values here. Now let's do the same thing with our next one here. If I take this and create that same kind of table where I know I have to add to make a negative 12, well, things that will, or if I have to multiply to make a negative 12, I should say. If I have to multiply to make a negative 12, but then add to make k, so things that multiply to make 12 are going to be 3 and 4, 2 and 6, 12 and 1. Now, what does this mean about the sum? Well, the sum could be, if they can add to be k, then this would be 3 plus 4 is 7, 2 plus 6 is 8, 12 plus 1 is 13. And remember, because we could also have a negative involved here, we also could realize that in order to have something that would multiply to make negative 12, any of these could be a negative here. So we could also get possible values where one of these are negative. So in the example of, what if this was negative here? Well, in order for 12 to be negative, when we multiply, one of them has to be negative. So let's say these ones are negative. We're going to go back here and fix this. The sum 3 minus 4 is equal to negative 1. We have 2 minus 6 is negative 4. And then 12 minus 1 is equal to 11. Now, I could do this the opposite way and say, what if? Now, instead, I put the negative in front of the other term, negative, negative, and negative. Well, then the sum would be negative 3 plus 4 is positive 1. Negative 2 plus 6 is positive 4. And finally, negative 12 plus 1 is equal to negative 11. So it can yet again be the plus minus of all the factors that work to multiply to make that value. All right, now finally, determine a positive and negative integer value of k such that the x squared plus 5x plus k could be factored. How many possible values of k are possible? So I know based on this trinomial, it always has to be that we multiply to make the outside term, and then add to make the middle term. So we need something that adds to make 5, but that multiplies, or that is the product k. Okay, so if I need to add to make 5, well, things that add to make 5, we could put in 6 and 1, or 6 and -1, I should say. We could put in things like even, if we have to add to make 5, we could put 2 and 3 maybe. And so this is actually a prime example of a positive and a negative version. Is if I wanted something that was a negative for k, well, we know these things multiply to make k. 6 times -1 is -6. 2 times 3 is +6. So we can actually say that k could either be plus or -6. Now we just want to think about any other examples. Things that would add up to make 5. We could have things like maybe 4 and 1, and the product of that would be 4. We could have possibly, I don't think there would really be anything else in these. We could have larger things that subtract maybe to get this. So it's possible we could have something like, if it has to add to make a +5, I could maybe put in 13 and a -8. And when we multiply 13 and 8, we're going to get a quite significantly large number here. So when they talk about a positive and negative value, well, we gave an example. A positive and a negative value for k, one is negative here, this one is positive, and the 4 is positive, so these are both examples of the positive. But how many possible k values are there? Well, there could realistically be infinitely many, especially when we can have a positive and a negative difference here.